In section 9.4, we're going to do something called partial fractions. For those of you that are going to end up taking calculus, you will revisit this in calculus when you do integrals and integration. So we're going to be breaking apart fractions that they give you into the components that are going to create that original fraction. There are 4 sets of directions with this. So step 1 is to factor your denominator if it isn't already. Some of your homework questions do go ahead and give that to you in factored form, so you can skip that step. In step 2, you're going to create your numerators. Now, these are always going to be 1 degree less than the denominator, so I'll show you how to do that in our first example. And then you're going to clear fractions, and then you're going to set up your system of equations and solve. So let's get to it and do a few examples. So in this first example, they've gone ahead and factored it for you, and they are giving you f of x equals and g of x equals. So the thing that you have to understand is that f of x is going to be the function that has to go over x minus 1, and then g of x is going to have to be the one that goes over x minus 1 for f of x and x plus 1 for g of x. So what we're going to do is go ahead and rewrite this using 1 degree less. So the degree of this is 1, so I just need a constant up here that I'm going to call a. And then in the second one, this is also a degree 1, so 1 less than that would be a degree of 0, which is just a constant. So once I have that worked out, we are going to clear fractions. Now, when you clear these fractions, the first thing that you need to understand is that you're always going to be multiplying every single term by this original factored denominator. So if I multiply this fraction by x minus 1, x plus 1, I have to do it to this one as well, and I have to do it to the last one as well. And what happens when you do this is that you're not going to have any more fractions to deal with. So these all cancel this, so there's just a 6 left. This cancels your x minus 1, so I have a times x plus 1. And then this cancels the positive, so this is b times x minus 1. All right, so now we're going to distribute our a and our b. So we have ax plus a, and then I'm going to add to that bx minus b. And then we're going to put like terms together. So I'm going to have 6 is equal to, so ax and bx can go together. Its coefficient would be whatever I get when I add a plus b, and that would be in front of the x term. Now, the constant that I have is a minus b, and I collect those and put those together. Now, what you're doing at this point is comparing what you have on the left, and you're setting it equal to what you have on the right. So over on this side, we don't have an x value, so I'm going to put 0x out there as a placeholder. So this 0 has to be equal to a plus b, and this constant 6 has to be equal to a minus b. So I have a plus b is equal to 0, and I have a minus b is equal to 6. So this is our system of equations, and this one's fairly simplistic because all I have to do is add. So in this next one, they've not factored it for you on the left-hand side, but they have broken it apart into x minus 2 and x plus 2, which is what the denominator will factor into. We're going to call this side A and this side B as we work through. So the next thing we're going to do is multiply x minus 2 times x plus 2 on all of these fractions. So that's going to clear the first one. That's going to leave A multiplied by x plus 2, and it's going to have B multiplied by x minus 2. So now we are distributing the a and b. We have ax plus 2a, and we have bx plus 2b, or excuse me, minus 2b. And then we collect our like terms. So we have a plus b will be the coefficient in front of x, and then 2a minus 2b is our constant. So just like before, this side does not have an x, so we put 0x, and this will be equal to that, and 36 will be equal to that. So this gives us our system of equations. A plus b is 0, and 2a minus 2b is equal to 36. So this time it makes sense that we're going to get rid of b since it's already negative up there. So I'm going to multiply the top by positive 2. I'm going to write that down here. So I have 2a plus 2b is equal to 0. And then when we add this, we have 2a plus 2a, so that's going to give us a 4a. And our b's are gone, and then we get that that's equal to 36, so a would be equal to 9. So then we go and we have a plus b is equal to 0, and then if a is 9, then of course b is going to be negative 9. Again, don't get in the habit of thinking that these are always going to work out this way, because they don't. So you'll take those two numbers back up to the top. So we have, in this first one, we'll have our positive 9 will go here. F of x is positive 9. And then for g of x, we have a b value of negative 9. So now we've grown to the part where nothing is factored out for us. And I will tell you that you do not ever want to factor out the numerator. All right, so we are going to keep negative 2x squared minus x minus 46. You're going to leave that alone. You're never going to want to factor your numerator. Now, in this denominator, I'll do it in a different color. We're going to factor right below it. So our GCF is x squared, so that leaves me with x plus 2. And then the GCF of the next 2 is 9. And when I factor that out, I'm left with x plus 2. So our factored form then, I will take those twins of x plus 2, and then we will still have what's left would be x squared plus 9. Now, because that's addition, that will not reduce or simplify any farther. I cannot factor that any farther. So I'm going to put x plus 2 here. This degree is 1, so the degree in the top would have to be 0, so that's just a constant. Now, for the first time in these problem sets, we have an x squared terms in the denominator. So this is degree 2. So for degree 1, we're going to have mx plus b. So we're going to call it bx plus c. But the only thing we're doing right there is writing it as mx plus b. It's that form. So that is our linear form. And we just use the next variables in the alphabet to come up with that numerator. So as we continue with this problem, of course, we're going to multiply by the denominator all the way through. So this is still negative 2x squared minus x minus 46. Then we're going to have a, and it's going to be multiplied by the x squared plus 9 because the x plus 2's would cancel. And then we're going to have bx plus c, and that's going to be multiplied by x plus 2. So as we continue working with this, the left side just stays the same. So it's just negative 2x squared minus x minus 46. I distribute my a, so I have ax squared plus 9a. And then here we have to use FOIL or box method. So I have bx times x, so that's bx squared. I have bx times 2, so that's 2bx. Then I have c times x, and then I have 2c. So again, left side stays the same. And now we need to collect all of the terms that are like terms. All right, so I'm going to highlight these. This is an x squared, and so is this. Then we have x's here and here. And then this has no x, nor does this. So those are the terms that go together. So as I collect my pink ones, I'm going to have a plus b will be the coefficient in front of x squared. So that's going to be equivalent to negative 2. That's what this will be. Then we collect our x terms, which is going to give us 2b plus c in front of x, which will be equivalent to this being equal to this -1. And then lastly, we're going to take our constant terms together. So that is going to be 9a plus 2c. And of course, my constant is equal to -46. So this one's a little bit longer. All right, you have a plus b is equal to -2. You have 2b plus c is equal to -1. And then we have 9a plus 2c is equal to -46. So what you have to do here is get something together and cancel one out. So what I'm going to do is put these two together and get rid of the c. So that's going to give me 9a plus 2c is equal to -46. And then I have 2b plus c is equal to -1. So I need to put a -2 right here. So I'm going to multiply that second line by -2. So I'm going to keep the 9a and 2c and -46 just like they are. And then I'm going to multiply that bottom line by -2. So I have -4b minus 2c is equal to 2. So when we add that together, we have 9a minus 4b. My c's are gone, so then I've got -44. And now we're going to take the a plus b is equal to -2. And at this point, you can solve to eliminate a or b. -4, so I'm going to multiply here by 4, here by 4, and then if I multiply the other side by 4, I get -8. And when we add, we get 13a is equal to -52. So we know that a is equal to -4. So once we have a, we are going to go and put this in to a plus b equals -2. So if I have a plus b is equal to -2 and a is -4, then I know that b is equal to 2. So there's my second one. And last but not least, if I use these two and I plug it into one of the equations with c in it. So I can do b plus c, or I can do 9a plus 2c. It doesn't matter which one we use. I'm going to use the 2b plus c is equal to -1 because my numbers are smaller. So I have 2 times 2 is 4 plus c is equal to -1. And that gives me that c is equal to -5. So there are my three numbers. And we're going to take these three numbers and go back to where we were looking at the original decomposition. So I have -4 to -5. So up here we have -4. Then we have 2. And then c we know is -5. So we would also erase the plus sign and just make that 2 minus 5. So you would type that in if it didn't already start with f of x and g of x. So on this last example, it is not factored in the denominator for you. So we're going to have 2 denominator factors. So if you slide and divide, you get x squared plus 5x plus 6. So I have x plus 2 and x plus 3. And then I have to divide each of those by 6 and reduce. So we have x plus 1/3 and we have x plus 1/2. So my two factors are 3x plus 1 and the other is 2x plus 1. So again, the order that you put these in over here does not matter. You just have to make sure that you find them and factor properly.
So I'm going to erase this factorization. So now we have to write our numerators 1 degree less. So both of these have a degree of 1, so I just need a degree of 0 top and bottom. So we get just a constant a and a constant b. So now I clear fractions. So I have x plus 3 is equal to a times 2x plus 1. And I have b times 3x plus 1. So we still have the x plus 3. This side we have 2ax plus a plus 3bx plus b. And we collect our like terms. So we have 2a plus 3b times x, or in front of x rather, that's the coefficient. And then my constant, of course, would be what's left, so that's a plus b. So 2a plus 3b is equal to, the coefficient on x over here is, of course, 1. And then we have a plus b is equal to 3. So for this one, we can choose a or b. It doesn't matter to me which one you choose. I'm going to choose a, so I need to create a -2 on the bottom. So I'm going to multiply it by -2 all the way across. So we have -2a minus 2b is equal to -6. And then rewrite the top equation next line down. So I have 2a plus 3b is equal to 1. And when we add, of course, our a's are gone. Then I have 3 minus 2 is b. And -6 plus 1 is -5. And then we go back to a plus b equals 3. And we get that if b is -5, then a is going to be equal to 8. And again, you always want to take these two numbers. I'll highlight them both in red. We have an a value of 8 and a b value of -5. We're always going to go back up to the beginning and put those in. So we have 8 is a, and b is -5. Now, if these are pre-assigned for you, then you can just put that in there. You can also see it written so that this just becomes a minus sign instead of adding a negative. Just pay attention to which way it gives it to you. See me with questions.